All right, today we're going to peek under the hood of Swift, the language that powers so many of the apps you use every day. We're going to look at this hidden decision-making process that happens constantly behind the scenes every single time you run some code. It's a really core concept that's all about balancing pure speed with raw power.
So let's just jump right in. Think about it for a second. You write a line of code, you call a method, to make a character jump in a game or to slap a filter on a photo. But have you ever really thought about how Swift knows which exact chunk of code to run, especially when there could be a few different options? Well, that's the big question we're tackling today. In this whole process, it has a name, method dispatch. It's just the fancy term for how Swift makes that split-second choice to run the right method. It sounds simple on the surface, right? But how it makes that choice has some pretty massive implications for how your apps perform and how flexible they can be. Okay, so Swift basically has two main ways to handle this. Let's start with the first one, which I kind of think of as the fast path. It's called static dispatch. And the key thing to remember here is that this is all about making the decision at compile time. That's before your app even starts running. With static dispatch, the decision is locked in before your app ever launches. This is what makes it the absolute fastest way to do things, because there's zero guesswork when the app is live. The compiler already figured out the exact memory address of the code it needs to call. This is the go-to method for things like structs and enums, or any method you specifically label as final, static, or private. Basically, any situation where there's no question, no ambiguity at all about what needs to run. Let's look at a super simple example to really nail this down. We've got a dog struct here, and it has one method, bark. So when you create your dog and you tell it to bark, the compiler doesn't even have to think. It knows D is a dog, and there's only one bark method in the universe it could possibly be talking about. So it just wires that connection up directly. It's instant. No hesitation, just pure speed. So if there's one thing to burn into your brain, it's this. When you hear static dispatch, you should immediately think performance. There's no need to look anything up while the app is running, which makes it incredibly efficient. You can think of it as the sprinter in this race. But what happens when you need more flexibility? What if you don't know exactly what kind of object you're dealing with until the app is actually running? Well, that brings us to the second path, dynamic dispatch. This is all about making the decision at runtime. Dynamic dispatch is all about having the power to choose later. The decision gets postponed until your app is live and in the user's hands. This is absolutely essential for building more complex, adaptable code, especially when you use inheritance. Under the hood, Swift uses a sort of address book. It's called a vtable to look up the correct method for the actual type of the object at that very moment. So, picture this. You have a general animal class, right? And it has a speak method. But you also have a more specific dog class that inherits from animal. And you've overridden speak to make it print bark. Now, look at the code. We're creating a dog, but we're storing it in a variable that's typed as animal. So at compile time, all Swift knows is that A is some kind of animal. It's only at runtime when a.speak is called that Swift says, hold on, let me check. This thing is actually a dog. And that is when it decides to call the dog's version of speak. That's dynamic dispatch right there. The big takeaway here is flexibility. Dynamic dispatch is the magic that makes object-oriented programming so powerful. It's what allows one piece of code to work with all sorts of different objects in a really clean way. So if static dispatch is the sprinter, dynamic dispatch is the gymnast. Incredibly powerful and adaptable. Okay, so we've met our two contenders, the sprinter and the gymnast. Now let's put them side by side and really dig into the trade-offs between speed and flexibility. This table just lays it all out nice and simple. First question, when's the decision made? For static, it's at compile time. For dynamic, it's at runtime. Okay, what about performance? Static is definitely faster. Dynamic is just a little bit slower because of that runtime lookup. Can methods be overwritten? That's a hard no for static, but a huge yes for dynamic. That's its whole reason for existing. And finally, where do you see them? Static is king in the world of structs and enums, while dynamic lives in the world of classes and inheritance. So at the end of the day, it all boils down to this one fundamental trade-off. On one hand, you've got static dispatch. The decision is made early and you get blazing fast performance. On the other hand, you have dynamic dispatch. The decision is made late, which is a tiny bit slower, but it gives you incredible flexibility to build complex, adaptable systems. So why are we talking about this? I mean, who cares about these internal mechanisms, right? Well, this choice actually matters a whole lot.
Let's zoom out from the code for a second and see how this stuff has a real impact.
Yeah, this is not just some academic theory. It's a core design philosophy of Swift itself. The language was built from the ground up to be both super high performance and really flexible for building big, complicated apps. This whole dispatch mechanism is where those two ideas meet. So when a developer chooses to use a struct instead of a class, they are making a conscious decision. They are choosing the raw speed of static dispatch. It's how they balance performance with architecture to create apps that feel both powerful and snappy. And that kind of brings us to the final thought. The next time you're using an app and it just feels ridiculously fast and responsive, or you see one that has a really complex, elegant interface, just stop and think for a second. Could that perfect balance of speed and flexibility you're feeling, could it all have started right here with a simple fundamental choice between static and dynamic dispatch? Chances are, it probably did.